So we're dealing with the 2005 Chevy Tahoe. This is the one that had the extended crank regarding the evap purge valve with the new part yesterday. I'll tag that video in the description. The other code that was coming up was the vent circuit, and that's what we're going to go to today. So we had an evap vent solenoid control circuit. We're going to check the circuit integrity, and he wants to go ahead and replace the knock sensor. Typically, knock sensor just fails, so we're going to replace both of them and check the connector and just replace the sensor, because usually this is what gets resolved. And I know I'm kind of guessing that one, but we're talking about this one right now. So we're going to go right under the vehicle at the charcoal canister, do some basic bidirectional tests, test the vent circuit and see what is going on with it. Same as the evap purge valve, but we're just going to go in the back and do it. So here's our vent circuit. This is going to be very simple. I'm going to log into my scan tool. Let's see if I can get that shown here. Luckily the spare tire is not in the back, so it made life a little easier. So we're going to exit out, go into the active test function inside the engine. We're going to go to vent solenoid right here, and the only thing I'm going to be able to do is just activate it on and off, and this is what's going to give me the circuit integrity. I'm going to use my test light as a load circuit. That's going to emulate this vent solenoid here. So if this circuit is proper, the only thing it's going to do is just illuminate the test light. Very easy. It don't get no more difficult than this. If there's a problem, make sure the pin fitment's good too. Sometimes those spring, like leaf spring looking retainers for the pins will fail. I've had that happen on the vehicle recently where I overlooked it. So simply put, this is just going to be my load circuit. Once I activate it and then illuminate, we're going to be good. So the key's on, engine off. I hit that on button. Oh yeah, so it's on. I'm going to hit the off button. It goes off. Simply put, we just got a bad solenoid here, a vent solenoid. And what happens, that continuity inside the solenoid doesn't backfeed, and I'm going to show you what that looked like when we bench tested. So right now I got to figure out how to get this off so I can get this replaced. Push down and back up. There we go. And then all I gotta do is get this off of there. There we go. So basically right now, we're going to do a circuit integrity test. And I'm going to show you what the computer essentially have to see to generate this fault code. This is the only time where an ohm test is going to work. A lot of times, you know, they're just irrelevant. Test my test meter here. We're fine. 0.3 ohms. We need to see about, I would imagine, like 6 ohms or something. And we're at 2 mega ohms. That is extremely high. The resistance is extremely high. It's like nearly an open circuit. So let me go back to volts, direct current, and I'm gonna put my black lead here on battery negative, and this is a live wire here. This is measuring 12.47 volts. This is a complete circuit. The computer needs to see that there's some sort of feedback registry here. So this is where it does its circuit integrity test. It'll send 12 volts, a live 12 volts through that wire. The activating circuit inside the computer, despite it not being activated, it is capable acknowledging that there's 12 volts there. Once it detects 12 volts, then it thinks it's fine. This is only producing 10 volts. And I'm pretty sure at some point in time, let me see if I can put this together and we can hit it and see if it makes any change. it go open? I think that's me. Yeah, did it go open? Still about 10 volts. So it's a possibility what may be happening, like the code setting criteria may be key on, engine off. There needs to be between 10 and 14 volts for the vent circuit for like 10 seconds or something. And if it sees anything below 10 volts for a sustained amount of time, it's going to generate a code. We saw that this wasn't activating, and then we see it doesn't meet the back feed that needs to happen. So this is not generating 10 volts, 12 volts. So it's not sending voltage back to the computer that's willing to acknowledge that this circuit has good integrity. Let's see if we add powers and ground, if it activate. It didn't work when it was in the vehicle. Let's try it while it's out. All right, so I just got a regular old multimeter. I like my Harbor Freight one a lot better because the cheapos are easier to read. I think I messed up my fluke too. That thing is like 15 plus years old. But I got it on amps. This is going to measure the amp draw. So I'm on the ground here, and I'm just going to loop back in to the circuit and see if we get a draw. And there's no continuity. It's not doing anything. It's not even measuring any amps because it's not working. I'd imagine it would make like 1 amp. It's not doing anything at all. My test meter worked. Let me go back here. Let's do a resistance test real quick. Yeah, the test meter works. So this unit's just defective. Let's go get a new unit. Y'all know I frequently patronize the Raleigh's Auto Parts. Likely I'm just gonna get a standard product. We'll see if it's standardly fail or not. But hey, I support that company. I'll be back. Just made it back from the parts store. Y'all know, like I said, I frequently patronize the Raleigh's Auto Parts. Very bittersweet relationship. Here's the part number. CVS6. Standard product. The vent valve. It looks identical. Look exactly the same. There we go. Exactly the same. So let's do the same test with the back feed. It's testing the circuit with the new one, and we're going to see if we have that same circuit integrity test. Remember before, this old one was right at 10 volts. The computer needs to see around 12 volts feedback, and this one's making 12.36 volts. Let's go back to the old one. PCM needs to see 12 volts. Oh, now it's changing. The resistance value has changed, so I wouldn't be surprised because of the temperature or just the movement just in general that the circuit's going to be altered and disturbed. And yeah, so it could be a plethora of things causing this vent solenoid to lose its continuity. But at the moment, we saw what we saw. There was a lot of dirt in there. I'm sure that has something to do with it. That could be a thing where it got stuck. Let's do a amp draw. But before, that one would not activate. Let's see if the new one works, and let's look up how much amps is drawing out of the circuit here. Uh-oh, I'm on the wrong one. There we go. So 0.59 amps. So 500 milliamps. 590 milliamps about. So not quite 1 amp. So this is a working unit. You can hear it. Before, the other one wouldn't even do it. Let's just pull this one up. Nothing. Not doing a thing. The circuit's just dead. We didn't have any feedback, which gave us that code, and we had no activity. Despite the resistance changing as it sat for about an hour or so and me messing around with it, it's still broken. So we're going to put this back in there and see that this code has no immediate return. So that circuit fault can definitely be fixed. by putting this new unit in here because we have a good integrity test, unlike the old one. Let me start it up right quick. Should go through a test. Let's see if it came back. There we go. So it's immediate comeback. Come on here, man. Yep, there's the code. It comes back immediately. Let me clear it one more time. As soon as you start it. There it goes. Same code, because that in circuit integrity test. Yep. Vent solenoid control circuit. Let's put a new one in.
So we'll lock in place. There we go. I'm gonna put a little bit of lube around there so it wouldn't make it difficult getting it back off if I have to in the future. Just a little bit of dielectric grease. Just a little bit. Pull the connector off, electrical connector. Slide that back in there.
I got a key in the on position. We're gonna clear this code. So we got the new part in there. I'm not gonna worry about doing a bi-directional test because there's just no point, being that we already tested the circuit, tested everything out of it while it was out. Let's see here, should be no codes, and there's no codes. So yeah, that code is officially fixed, because before it would instantly come back. Other than that, that's pretty much the basics of this evap vent valve circuit code. That it needs to see that 12-volt feedback. If it can't see it, it's going to generate that circuit code, and we know what it's like, what needs to happen. We've been through the proper tests. We tested everything externally outside on the bench or on the barrel, and we have a fully functioning system now. We know the computer is capable of working because we bi-directionally controlled it and commanded to operate. We know that the circuit has integrity because we did the feedback loop. We're good. So if anything happened, I'll definitely update. That part was a little over $40 if you was to, I guess, buy it at a walk-in price. But she's good, man. Hit the link, subscribe to the channel, stay informed, how to reach some work. I'll see you on the next one.